Everybody, my name is Alex, and today I'm going to present you the MultiversX CLI tool. Before we start, I want to say that all the resources presented here will also be available to you. Links to the documentation and to the GitHub repository will be also provided. Let's get started. What is MXPY? MXPY is a CLI tool facilitating the interaction with the MultiversX blockchain and with smart contracts. Some of its key features are generating wallets and converting wallets from one format to another, creating, signing, and sending transactions, deploying, executing, and querying smart contracts, but also many more. For a full list of available features, we can use the --help argument, which you'll see later in this workshop, but also we can check out the documentation. Let's move on to installing MXPY. The recommended way of installing MXPY is using pipx. As you may know, pipx is a tool that helps us run CLI apps. So I'll just switch really quickly to my terminal, and if I type pipx --version, you can see that I already have pipx installed, and that's the version 1.7.1. Don't worry, we'll also provide you the link to the official pipx documentation, and you can install it from there. Once I have pipx installed, we can simply type pipx install MXPY, and what it does, it downloads and creates a virtual environment for MXPY. As you can see, it says that installed package MXPY 11.1.1. So now, just to make sure that it's been installed, I can simply type MXPY-v or --version, and we can see that indeed I have the MultiversX Python CLI 11.1.1 installed. So what we can do now, we can simply use the --help command or argument or -age to see a list of all the available command groups that MXPY provides to us. Now, if you have an older version of MXPY, you could also use pipx to upgrade to the latest version by simply typing in pipx upgrade MXPY, and what this does basically checks for the latest version. It compares it to the local version, and if the local version is outdated, it simply installs the latest available version. Now let's move on to creating wallets using MXPY. We have a couple of available wallet formats that we can choose from. The first one is raw mnemonic, which is the secret phrase in plain text. We have a format called keystore mnemonic, which is also the secret phrase stored as a password encrypted JSON file. We have keystore secret key, which is basically the secret key stored as the JSON encrypted file. And we have the PEM file, which is the secret key, but simply saved in as a PEM file. So that's not encrypted at all. PEM files are not really recommended for storing cryptocurrencies, but they're very easy to use for testing purposes. So that's the wallet format we're going to be using mostly today. So if we want to create a new wallet, we can simply use the wallet new command of MXPY, to which we'll have to pass the format of the wallet we want to create, which is keystore mnemonic in our case, and we also have to specify the out file, which will be called keystore.json. So if I just copy this command really quickly and then I move to my terminal and press enter, we see that this has generated a mnemonic, which is this right here. Our wallet address is this one, and I'm also prompted to enter a password for my keystore file. So I'll simply type password now. Okay. And now we can see that it indeed stored the wallet at keystore.json. So now if I simply move to my workshop file and then I open this as a text, we can see that this is the file it created that contains the mnemonic, the encrypted mnemonic basically. So yeah. Now let's move on a bit to how we can convert a wallet to another format. Keep in mind that not all the available formats can be converted to one another. Some wallets are some types are irreversibly convertible to other formats. So how we can convert the wallet? We can simply use the MXPY wallet convert command, to which we'll have to pass an argument to specify the format of the actual wallet, which is keystore mnemonic. So as you see, we have --in format, keystore mnemonic, and the file that stores the wallet, which is keystore.json. And we also have to specify the out format that we want. So we want to get a PEM file, and that will be saved in the file called wallet.pem. So if I copy this command really quick and I move back to my terminal, I paste it here. We see that it again prompts me for the wallet password, so it can decrypt the wallet. Again, I type password, and now we should have a file called wallet.pem. Indeed, we do, and this is how the okay. Let me just open it really quick. Where is the text app? Text edit app. Okay, so this is how a PEM wallet looks like. It has the batch32 public key and also the secret key. So we also now, before sending transactions, we also have to fund our wallet. For that, we could use the faucet available on the MultiversX web wallet, but we also have a command for that through MXPY. So if I simply type MXPY faucet.h, we can see that we have a request command. So let me just do request.h, and now we see that we should provide the PEM or any other wallet types. We could, if we had a JSON wallet, we would have been providing the key file argument and so on. So we'll simply provide the PEM that we want to fund, and that we also have to specify the chain ID. So as you may know, we also have besides the mainnet network, we have a Devnet network and a Testnet network, and we're going to be using the Devnet today. So I simply type MXPY faucet request --pem. This is the wallet.pem file, and --chain D for Devnet. Now, if I press enter, it should take me to the web wallet. I complete the CAPTCHA, and then I request the tokens. And now if I reload this transactions page, we see that indeed I am receiving 5x EGLD. So that's EGLD for the Devnet network. I can also go to the Explorer and see that the transaction has been completed, and that now I have the funds available. Cool. Now we're going to move a bit to creating and sending transactions. First, we're going to create a move balance transaction. So basically, we're going to send the native token. As you can see, we use the txnew command, to which we pass the wallet that we're going to be using, which is wallet.pem, the one that we just funded. We're going to specify the receiver. We're going to use this address. This address we call Alice. That's kind of a public address. Everyone can get the PEM file and use this address for testing purposes and so on. We also see that we have to provide the value that we want to send. Keep in mind this requires the denominated amount of EGLD that you want to send. So the very big number you see here is basically 1 EGLD, but because it has 18 decimals, we have to type it like this. So that's 1 followed by 18 zeros. That's 1 EGLD. Then we simply specify the proxy that we want to use to send the transaction. So we're going to be using the Devnet gateway today, but we could also use Devnet API or some other third-party API provider, and then we're going to simply specify the --send flag to also broadcast the transaction on the network. If we didn't use this, the transaction would simply be created, but it wouldn't be broadcasted to the network, so it wouldn't be processed basically. So if I just copy this comment really quick and paste it inside my terminal, we can see that's exactly the same one that I've showed you before. I press enter, and we see that we get a JSON representation of the transaction that we just sent. So we specify the value. That's the receiver. That's Alice's address. That's our wallet's address. And then again we sent one EGLD. The chain ID was set to D because it was fetched from the gateway that we provided. And if I click this URL here, it takes me to the Devnet Explorer, and we indeed see that we've sent from our address to Alice one EGLD. Cool. Now let's move on to sending ESDT tokens. This is very, very similar to sending the native token. So basically we use the same command, MXPY takes new. More or less we provide the same arguments. So we use the PEM file again. We specify the receiver that we want to use. So that's Alice in our case. Then instead of specifying the value, we're going to be using the token transfers argument, to which we also have to provide the token identifier and the full amount of the token. So that's again the denominated amount. And then we also going to specify the proxy and the send flag. So because we just created our wallet and it doesn't have any ESDT tokens, neither fungible or NFTs or SFTs and so on, we're going to be using Alice's address to send from this time. So let me just copy this transaction really quickly. I move to my terminal, and indeed we see that we've sent. We will send to this address. That's another public address that we call Grace from Alice's PEM that I also have saved in this directory. We're going to use the token transfers argument to send the token 183A7C0. Again with the denominated value, so this token has 18 decimals as well, so that's 1 followed by 18 zeros. And indeed I don't think this token still exists, so I'll just go really quickly to the Explorer, and that's Alice's address that we're going to be using. I simply go to NFTs and I copy one of these NFTs. Now, if I move back here, I'll simply paste it over this one. So that's it. Okay, so that's a fungible token. So it has no nonce. That's the identifier, the ticker followed by the random sequence and the amount. And if you want to send multiple tokens, we simply put them all here as a list, let's say. And this is our NFT. So it's called MNY. It has this random sequence, and here it also has to have the nonce. No, now keep in mind this should be the hex encoded nonce. So if the nonce of the token, let's say, would have been 10, this would have been 0A because it's hex encoded, and because this is an NFT. We also have to specify the amount that we want to send to be 1 because we also send 1 NFT. Now, if I hit enter, we're going to see that it indeed created a multi-SDT NFT transfer. And now, if I click on the transaction on the Explorer, we see that indeed we've sent from Alice to Grace one token and this this NFT that we've pasted in our command previously. Cool. Now moving back to our presentation, we're going to be now interacting with smart contracts. Within MXPY, we can deploy, upgrade, call, and query smart contracts, but we cannot build them. So for that, we're going to be using a tool called SCMeta. A link to SCMeta will also be provided in the description. That's our tool for creating and testing and building contracts. I already have it installed, so I won't install it now, but there is a detailed page on the documentation on how you can do that. So if I go to my directory really quick, we see that we have this other contract. That's a pretty simple smart contract. Basically, it only has two endpoints. It has an endpoint called add that simply adds a value to the value stored in the contract. And it has a function called getSum that basically returns the value stored in the contract. When deploying the contract, we have to pass it the value that it will be counting from. So usually we pass it 0 so that it starts counting from 0. And then each time we call the function add, it increments the value with the specified value. But we'll see later in this workshop. So to simply build the smart contracts, I will use the SCMeta CLI tool. So I simply type SCMeta all build, and then using --path, I specify the path to my other contract. And now we see that indeed it builds the contract. Now, if we switch back to our contract, we see that we have this output directory where the ABI file has been generated. That's the contract interface, and the WASM file. This is the bytecode that we will be deploying on the network. So to do this, we're going to be using the MXPY contract deploy command. Again, we're going to be using our wallet, which is wallet.pem. This is going to be the deployer and the owner of the contract. Using --bytecode, we're going to specify the WASM file. That's the bytecode of the contract. Then using the argument, we're going to be passing the value 0. So that's the value our contract will be starting to count from. And then similar as before, we're going to pass the proxy and the send arguments. So if I go back to my terminal and copy this command really quick, we see that's the exact same one that I showed you before. And now that's the transaction it created. And this is the generated contract. So it ends with N8F. And now if I click on this and it takes me to the Explorer, we see that indeed the transaction was successful. We did a smart contract deploy transaction. And I can also get the transaction address from here, which we see it's the same, N8F. So if I copy it and paste it here, this is our contract. And now each time a transaction is made to this contract, we're gonna be seeing it here. Now let's move on a bit to how we can call this contract. So for this, we're going to be using the contract call command, to which we pass the contract address as a positional argument. And after that, we're going to be passing the PEM wallet that we will be using. We're going to specify the function, which is called add. So that's the function we're going to be using. And then the value we're going to add is 7. And we're going to pass this value using the ---- arguments. And after that, again, we specify the proxy and the send flag. So if I just copy this really quick and move to my terminal, I also need to get the contract address. So I'll paste it here, just a second. Okay, so by using this command, we're gonna call the function name add with the value 7. I hit enter, and we see that it indeed the transaction data looks like it called add with the value 7. So if we go here on the Explorer, we see that the transaction status is success, and that it indeed called the function named add. We can also see the transaction appears in our contracts page. Cool. Now we can also query the smart contract. What querying a smart contract means, it basically calls a view function. So that's a function that only reads data from the contract. It does not modify the state of the contract. So this is not really a transaction. We simply use the API or the gateway to query a contract, so we don't have to send a transaction on chain for that. So for that, we're gonna be using the query command of MXPY, to which again we pass the contract address, and then we specify the function we want to call. So that's getSum in our case, but also we're going to specify the proxy, so it knows on which network our contract it's located. So if I copy this this comment here and paste it in my terminal, I'm gonna need the contract address again. So I'm gonna paste it. Sorry for that. I'm gonna paste it here. Just a second. Okay. Again, using the function getSum, now we're gonna query the contract. So because the contract stores the value as raw bytes and returns us the hex encoded value, we see that we received the string 07, which is basically, if we convert it to an integer, it's the value 7. So that's exactly the value we added to our contract when we called the add function. Yeah, so that was pretty much it for calling and querying smart contracts. Now, let's say you want to upgrade your smart contract. That's also available on MultiversX. Perhaps you want to patch a possible vulnerability, or you want to simply upgrade the code of your smart contract. You can do that. For that, you will be using the contract upgrade command of MXPY, to which we again pass the address of the contract that we want to upgrade. Keep in mind, this has to be done from the owner's wallet, so you'll need to be the owner of the contract in order to upgrade it, of course. And then you can pass it the new bytecode, so that's the code that will be replacing the old code. Again, with the arguments, if there are any arguments needed, again using the proxy and the send argument. So we won't be doing this today, but if you want to, you can basically. Keep in mind that's just a short example of what MXPY can do. For a full list of examples, use the --help argument to see all the commands that MXPY provides, or simply check out the documentation. So what we've done today is we've created a wallet, we've converted it to another format, we've also created broadcasted and signed transactions, and we've also interacted with smart contracts. So we've deployed, called a smart contract, and also query a smart contract. What we could do after this, we could check out the multisig commands. So we have dedicated commands for multisig smart contracts. You can basically deploy a multisig contract. You can propose a new proposal, you can vote for a proposal, and all sorts of things that the multisig contract supports. We have governance commands, so you could be creating a new governance proposal, or perhaps vote for a certain proposal, and so on. You could send guarded transactions. So if you use a guarded account, you could do that using MXPY. You can create a local net, that's a local blockchain on your machine. That's very good for testing purposes and so on. And we also have delegation commands that can be used to create a new delegation contract, to delegate funds and that sort of operations. So yeah, as I said at the beginning of this video, all the links will be available to you as well. Thank you for listening and have fun building. Bye bye.